Hey everyone. Today, we're going to talk about a programming language that has quietly become the backbone of the modern internet. It's called Go. And, its story all started with a huge, and I mean huge, problem inside Google.
And that's the big question, isn't it? Google has some of the most brilliant minds on the planet who have totally mastered languages like C++ and Java. So why on earth would they go through all the trouble of starting from scratch? Well, the answer reveals a problem of just massive, massive scale.
So, the story of Go really begins with a crisis. You see, by the mid-2000s, Google's software had grown so enormous, so complex, that their existing tools were literally starting to break under the strain. They were staring down a full-blown code crisis.
This slide really lays out the pain points for Google's developers at the time. Just imagine waiting forever for your code to compile, or trying to write code that could do a bunch of things at once, what we call concurrency, only to find it was unbelievably complex and just riddled with potential errors. Even basic stuff, like processing text from billions of web pages, was becoming a huge bottleneck. It was, simply put, a developer productivity nightmare.
So what did Google's engineers do? Well, they did what they do best. They engineered a solution. They decided to build a brand new language, from the ground up, designed specifically to fix the very problems they were battling every single day.
And this right here gets us to the core philosophy of Go: simple, fast, and concurrent. And listen, these weren't just some slick marketing buzzwords. They were the actual guiding principles meant to solve Google's biggest headaches. So let's see what that really means in practice.
Okay, so first up, Go is what's called statically typed. All that really means is when you create a variable, you have to be super clear about what kind of data it's going to hold, like a number or some text, and you can't change that later on. Now, why does that even matter? Because it makes the code incredibly reliable. The compiler, the tool that builds your program, can catch a ton of potential mistakes before the code ever even runs. That saves developers from those late-night bug hunts we all dread.
And this focus on simplicity and speed, it is everywhere in Go. Compilation is just lightning fast. The language itself has a very clean, minimal look, which makes it way easier to learn. Plus, it doesn't need a bunch of external frameworks to run, making it a breeze to deploy your applications. And it has this thing called garbage collection, which just automatically cleans up memory for you. The big takeaway here is that every single one of these features was put there to make developers faster and way more effective.
But, the real game changer, the one feature that truly sets Go apart from the pack, is its revolutionary approach to concurrency. This is, without a doubt, Go's superpower.
Now, before we go any further, we need to get a key distinction straight. Concurrency is about dealing with a lot of things at once. The classic analogy is one chef juggling multiple dishes, chopping veggies for one dish while a sauce simmers for another. Parallelism, on the other hand, is about doing a lot of things at once. That's like having multiple chefs, each working on their own separate dish. And let me tell you, Go is an absolute master of concurrency.
So how does Go pull this off? It does it with something called a Go routine. You can just think of a Go routine as a super cheap, incredibly lightweight instruction. So instead of just doing one thing at a time, you can launch thousands, even tens of thousands of these Go routines to handle tasks all at once.
Just how lightweight are they? Well, get this. A single Go routine starts with only about 8 kilobytes of memory. That is astonishingly small. It means you can have literally thousands, or even hundreds of thousands of them running in a single program without it even breaking a sweat. This is the magic that allows Go programs to handle these immense workloads with total ease.
So how does this whole philosophy of simplicity and power actually show up in the language's core building blocks? Let's take a look.
For really simple cases like a list of things that's never going to change size, Go has a very straightforward solution: an array. It's super efficient. But honestly, Go's real power comes from its more flexible tools.
Because let's be real, most of the time you need something way more flexible. And for that, Go gives us the slice. It looks a lot like an array, but the cool part is it can grow and shrink as you need it to. It's the more common, more powerful, and just more pragmatic choice, which is, very typical of Go's whole design philosophy.
Okay, so if you have thousands of these Go routines running around, how in the world do you keep track of them all? Well, Go provides a really simple tool called a wait group. Think of it like a checklist for a dinner party. First, you create the wait group. That's your checklist. Second, every time you launch a new Go routine, a new task, you add one to the counter. It's like adding a guest to the party list. Third, once a Go routine finishes its work, it calls done, basically checking itself off the list. And finally, your main program just has to wait until that counter hits 0.
It's a beautifully simple way to manage thousands of concurrent tasks.
So let's recap. We have a language that's simple, crazy fast, and an absolute master of concurrency. So where do you think a language like this would find its perfect home? Well, it turns out it's powering the massive, distributed systems that run the modern cloud.
You've heard of Docker, right? The technology that totally revolutionized how we package and run applications? Yep, it's written in Go. Its efficiency and simplicity were a perfect match.
Now, what about the tool for managing all those Docker containers at a massive scale? That would be Kubernetes, also a Go project. Managing these huge clusters of servers demands exactly the kind of powerful concurrency that Go is built for.
And how do you monitor all of that complex infrastructure? With Prometheus, the industry-standard monitoring tool, which is also, you guessed it, built with Go.
You're seeing the pattern here, right? It's just undeniable. From the foundational tools of the cloud to advanced databases like CockroachDB and even major blockchain platforms like Ethereum, Go is the language of choice for building reliable, high-performance infrastructure.
So let's bring it all together. Go wasn't just some academic project. It was a pragmatic, real-world solution to a massive problem at Google. And its core principles, simplicity, speed, and powerful concurrency, are the very reasons it became the essential language for building the cloud-native world that we all depend on today.
And that brings us to the end. Go started as a solution for Google, and it went on to power a whole technological revolution. It really makes you wonder, doesn't it? With its unique strengths, what groundbreaking new systems will be built with Go next?